students, today in this video we will explain the structure, properties and application of graphite. Graphite is an allotrope of carbon. So as is in the case of diamond, the graphite also contains the carbon atom. In graphite, mainly the atoms are arranged in layer. In graphite itself form in two allotropic form. One is beta graphite, and beta graphite is also known as natural graphite, and other one is alpha graphite, that is synthetic graphite. So natural graphite or beta graphite mainly forms in a hexagonal forms, and synthetic graphite it comes in a rhombohedral forms. Okay, so in graphite the carbon show the sp2 hybridization. That means the sp2 carbon has a 3 hybrid orbitals at 120-degree angle in one plane. They forming a sigma bonds with 3 other carbons and a unhybridized orbitals at right angle to the plane. Now each of these sp2 hybridized carbon combine with each other to form a sheet of hexagonal arrangement network. So each carbon atom an unhybridized p orbital, and together due to the resonance they form a ring of delocalized electron. So in the structure of graphite हम directly इसके diagram को ही देखेंगे. In this structure we will see that the hexagonal, each carbon atoms, they will form a hexagonal form of graphite, and each carbon atom attached with the 3 other carbon atoms, and they will form the sp2 hybridization. Okay, and during the sp2 hybridization they will attach with the 3 other carbon atoms by the covalent bond, and the distance between them is 1.42 angstrom. So this one is the each layer of graphite. So each layer of graphite attached with other layer of graphite by a weak van der Waals force of attraction. This weak van der Waals force of attraction makes graphite soft, slippery in nature and used as a lubricant, because the distance between the two layer of graphite is 3.4 angstrom. Okay, that's why it is very weak and it is soft, slippery and used as a lubricant in nature. Mainly the graphite also show the high melting point. It can be easily explained by that they having a covalent bond, the sigma bonds. So sigma bond is a strong bonds and they need a large amount of energy to break. That's why its melting point is very high. Okay, so mainly the 3 important characteristics in the graphite structure. Firstly, they will show the conductivity. The conductivity due to the sp2 hybridization. Okay, within each layer the carbon atoms are strongly bonded by a sigma bonds, and the bond angles are 120 degree with each other, and they link between adjacent layer with a weak van der Waals force of attraction. And the graphite show the good conductor of heat and electricity, because one of the electron which is free, that is the 4th electron, that will responsible for the conductivity. Okay. Now the properties of graphite. Graphite is a soft, slippery and grayish black substance. It will show the metallic luster, and it show the high melting point. It is already explained why. It is mainly insoluble in organic solvent and water. Graphite is a good conductor of heat and electricity, and specific gravity of graphite is very low. Now the properties, mainly graphite used in making, the common example is making pencils. Okay, as graphite is very soft and slippery in nature, that's why it is used in a dry lubricant. Being resistant to chemical and high melting point, it is used as a good conductor of heat. And as graphite having a free electron because of a sp2 hybridization, it is used in a electrode for conduct the electron. And graphite used in the nuclear reactor also to control the speed of the nuclear reactions. So these are the certain applications of graphite. Thank you.